Here in 2.3, we're going to be taking a look at slope and rate of change. We really have two objectives. Find the slope and the rate of change, given specifically 2 points or an equation, and work with parallel and perpendicular lines and their slopes. Just some vocab, making sure that we understand what we're talking about on these type of problems. When we talk slope, the slope of a non-vertical line is the ratio of the vertical change, the rise, and again, that's what most of us will probably remember about slope, is the rise. That's how far up and down we go. To the horizontal change, which is the run. And remember, the run is left to right between any 2 points on a graph. So how far up it goes and how far over to the left or right does it go is what we're talking about when we're talking slopes. The rate of change compares a change in one quantity to a change in another quantity. Now, when we hear rate of change or slope, there's a connection. Because if you notice, slope is the comparison of a change in one quantity and a change in another. And so you can see vertical change and horizontal change. And so the slope is a rate of change. And so that's important for us to understand, is when we hear rate of change, we're talking some type of slope of some sort. And specifically in Algebra 2, we're going to be talking about the slope given 2 points, or the slope of the secant, as you get into pre-calc and calculus. Now, there are 4 types of graphs that we're going to be encountering when we do linear equations, and we got to understand what the slopes are just by looking at them. Maybe not what the value of the slope is, but definitely is it positive, is it negative, and so on. And so when you take a look at this first one right here, we have this red line that's going upwards left to right. So it's, in my view, it's increasing. Okay, so as x gets larger, your y gets greater. And so what we say is that this slope right here is going to be positive. Okay. So if it's going uphill, left to right, it would be positive. Now if I wanted to know what the exact slope was, remember what the slope is a rise over a run given 2 points. Well, here's your 2 points right there and right there. So if we say, well, how far up do we go? Okay, so if I start here, it's sort of like this is like a GPS, and you're going from here to there, and it needs to tell you how far up you need to go before you take the turn. And so our rise is going to be 1, 2, 3. So the rise is up 3. Now, up meaning positive. Up's positive, down's negative. Right's positive, left's negative. And so we went up a positive 3. Then once we're here, it's going to say take a right. All right, and we take a right, and we want to know what the run is, or how far to the right do we go. And so our run is also going to be a positive, and it's going to be a positive 2. So our rise over run is 3 over 2. Our slope is 3/2. That would be the steepness of this line. Taking a look at the one in blue here, what we have is a line that's going downhill left to right. And so this would be more negative right here. So this is, the slope is negative. Now, once we realize the slope is negative, to verify that, let's go ahead and take a look at our 2 points again and sort of see what we got going on. So right here, we start either place, but let's start right here. And notice what we got to do to get to here is our rise. Well, we're not actually going to go up, we're going to go down. 1, 2, 3. I went down 3. So our rise, being down, would be negative 3. Then what we do is we go to the right, 1, 2, 3. And so our run is to the right, which means it's positive 3. And what you'll notice is that we have a negative 1 slope. That's the steepness of this line. So we have positive slopes, which is the first one. We have negative slopes, which is the second one. Notice on this one, this horizontal line. This is interesting. It's a little bit different because notice on this one, it doesn't go up or down. It goes left and right forever and ever. But the rise, how far up or down does it go? It goes nowhere. How far up do I have to go from this level to that level? Well, I don't go up anywhere. And so our rise is 0. Our run, on the other hand, 1, 2, 3, 4 would be a positive 4 because it's to the right 4. But really 0 in the numerator, 0 divided by anything, if you remember 0 divided by anything is okay. It just means that your answer is 0. So the slope of a horizontal line is 0. And that's something that you just definitely want to just memorize. Slope of a horizontal is 0. Now we take a look at a vertical line right here. And what you'll notice about a vertical line is there is a rise. So if I wanted to go from this point to that point, how far up do I have to go? 1, 2, 3, 4, so a positive 4. if I wanted to know what the run is, notice here I don't go to the left or right anywhere. So there is no run. There is no left or right. It's 0. Uh-oh. This is bad stuff. Okay, 4 over 0, no, any number over 0 cannot happen. That is undefined. We're going to talk about that in just a moment as well. Is this division by 0 as an undefined value? So the slope of a vertical line, sometimes you'll hear undefined slope. That would be fine. And on occasion you'll hear like no slope. Now don't get no slope confused with 0 slope. 0 is a value. So there's a difference between a 0 slope horizontal line and a vertical line which has a no slope or undefined. So it's so steep you can't run on a vertical wall. Okay? It takes 0 effort to run horizontally. It takes positive effort to run hill. Sometimes it takes negative effort to run downhill because the gravity's pulling. Okay? But those are really the 4 different types of graphs that you're going to encounter when you're dealing with linear equations and their slopes. Let's talk a little bit more about the formula to find slope, specifically given 2 points. And so what we have here is the slope of any non-vertical, because remember the slope of a vertical line is undefined. So I can't find the slope of something that isn't defined. So that's what they mean by non-vertical line, passing through any 2 points. So here's an ordered pair, and here's an ordered pair. Is the ratio of the rise, change in y's, to the run. Now, you may be thinking, well, okay, we got rise over run here. How do we represent that using 2 points? Well, what we want to remember is slope is equal to rise over run. And if rise is the change in y's, how do I represent the change in y's? And the run is the change in x's. How do I represent the change in x's? And if you look up here in the red box, this will give you the description of how we do this. If I wanted to go from here to there, to find my rise, I would go from the dot to this point right here. That's my rise. How far up is that? Well, notice if I drew a line all the way over here and a line all the way over here. What I have is I have some y value. We call it y sub 1. And then we have some other y value. We'll call it y sub 2 right there. So if I want to know the distance between those two, that would be the change in the y's, is the distance between those two. Then what we do is we take the top number minus the bottom number. If I want to know how far it is from 6 to 10, it's 4. How do I know that? 10 minus 6, top number minus bottom. So what we have here is we have y2 minus y sub 1. That would represent our rise. Then if I wanted to know the run, if I get rid of this stuff and I say, well, how do we represent the run here? Well, again, what we have is from here to there, or from this dot to that dot. So if I wanted to go from here to there, and that represents my run, how do I represent that distance? Well, again, I drop a little line, that's x sub 2. I drop another little line, that's x sub 1. If I want to find the distance in between, it's the top number minus the bottom number. So x sub 2 minus x sub 1, and that's your run. This right here is very important. This is what you would use to find the slope given any 2 points. Okay. Let's take a look at some of these in practice here. We have the graph over to the right, so obviously we can just do manually what's our slope. Well, up 1, 2, 3, so the rise is 3. What's our run? 1, 2, 3, 4, 5 rise. So it's 3 over 5. So we know where we're heading. Let's see if we can do it algebraically rather than through the graph. Okay, so what we have here is we have our 2 points, negative 2, 0, and 3, 3. And we want to go ahead and find the slope. So first off, we want to write the formula down. So you need to memorize it. So I would almost encourage you to write it down almost every single time because you have to memorize it. It's not something I'm going to give you. You'll definitely want to be able to utilize this without assistance. And so keep practicing writing it down, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Some questions students have are this. Does y sub 2 and y sub 1, can they be flipped? Can it be y sub 1 minus y sub 2? Absolutely, as long as it's x sub 1 minus x sub 2. So as long as the subtexts are lined up, subscripts, then you're okay. You can go ahead and do that type of ratio. However, you cannot flip the x and put the x's on top and put the y's on the bottom. So keep that in mind. That is not something that you want to do. Then what we want to do is we want to go ahead and substitute in our value. So I always have the students, and I want you guys to do the same thing, label these x sub 1, y sub 1, and x sub 2, y sub 2. And they were already labeled for us, but we'll label it right underneath. Then what allows us to do is then substitute in for those values. So y sub 1 gets 0, and x sub 1 gets a negative 2. So we're subtracting a negative 2. So you can see that right here on the next slide, or the next screen here. Right here, we got 3 minus 0 because we have x or y sub 2, 3, minus y sub 1, 0. And then we have x sub 2, 3, minus x sub 1, which is negative 2. So 2 negatives make a positive, so we should get 3 plus 2. And on top, we have 3 minus 0. So on the top we should end up getting 3, and on the bottom we should end up getting 5, which is our slope, and that's what we said it was earlier. It's a positive slope. Let's take a look at another one. Again, what we want to get down is what is the formula. Say the formula is the slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. From there, we go ahead and label our 2 points that they give us. So we'll call this x sub 1, we'll call this y sub 1, we'll call this x sub 2, and we'll call this y sub 2. And then we're substituting in for those values. So again, it's going to go 6 minus a negative 2 over negative 2 minus 4. So you can see that right there. 2 negatives make a positive, so we actually have 6 plus 2, which is going to be 8. And negative 2 minus 4 ends up being negative 6. So we end up getting 8 over negative 6. Now, we'll want to reduce that, and that's what the answer is going to have here. But we'll want to reduce it by 2, so we get 4 over negative 3 as our final answer. You can see that simplification right there on the screen. If we come over and just check ourselves with the line, we plot those 2 points. Notice our rise, 1, 2, 3, 4 down. So negative 4, 1, 2, 3. Negative 4 over 3 or negative 4 thirds is what we have. So that matches up perfectly with that. Okay, moving on. Now we don't have graphs to look off of, and really it's just we need to practice these problems. And so let's look at this one. Notice we have 2 points, and what we want to do is we want to label them. We find the slope given 2 points. We go ahead and put our formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now we want to go ahead and label x sub 1, y sub 1, x sub 2, y sub 2. And then substitute in for the values, 9 minus negative 1, and then over x sub 2, which is 5, minus x sub 1, which is negative 4. So a lot of double negatives here. So 2 negatives make a positive, so we end up getting 9 plus 1. And on the bottom, we end up getting 5 plus 4. So we end up getting 10 over 9 is our slope for that first problem. Take a look at the second problem. We do the exact same thing. We go ahead and write our formula that we're going to use, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Make sure you get it down. Then you label your 2 points, and then we substitute in. So we got 8 minus, what's y sub 1? Well, it's 5. So there's our top. Our bottom, x sub 2 is negative 7. What's our top? Negative 2. There's a double negative there. And so we get 3 on top. Negative 7 plus 2 is negative 5. And notice on this one, what we get is the slope of negative 3/5. All right. Moving on, we take a look at one like this. Now, what makes this unique, and you can see the graph, is that it's horizontal. Now, we shouldn't just memorize what the slope of a horizontal line is. We already know it's 0 from earlier. However, let's go through our steps, and let's make sure the formula shows us that, because if we don't have the graph, maybe we don't see that this is a horizontal line. So find the slope of the line shown. First off, you got to remember your formula. Y sub 2 minus y sub 1 equals x sub 2 minus x sub 1. From there, we go ahead and substitute in our values by labeling them. Here's x sub 1, y sub 1. Here's, x sub 2, y sub 2. And now we can go ahead and plot our points. And so we go, well, it's negative 2. So what we have here is negative 2 minus a negative 2. And then here we have 2 minus a negative 4. Now what you'll notice here is a negative 2 minus a negative 2 is actually going to be 0. And so what we have is we have 0 on top. And then on the bottom we end up getting plus 2 plus 4, which is 6. And so it doesn't matter. That's okay. 0 on top is okay. It just simply means the answer is 0. 0 over 6 is 0. 0 slope. That matches up with a horizontal line. Okay? Now, if we take a look at the next example, however, we want to be very careful, because what we're taking a look at here is, notice what doesn't change are my x values. There's no change in my x's. So there is no run. Now let's verify that, because remember, the slope of a vertical line is undefined or no slope. Let's see if we get that using our formula. So the formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You label x sub 1, y sub 1, x sub 2, y sub 2. And now we can go ahead and start plugging in. And so y sub 2 is negative 3, y sub 1 is 4, negative 3 minus 4, and then 1 minus 1 on the bottom. So on the top you end up getting negative 7. On the bottom you end up getting 0. And that's where we run into the issues right there. The division by 0 is undefined. Okay? No. Division by 0 is undefined. And so when we get this, it's not going to be a solution here. And so what we have is division by 0 is undefined. And I always tell the students that when you do this, worlds are colliding. You don't want to divide by 0. Worlds will collide when you do that. And usually it's worlds made up of bunny rabbits. Say. So we definitely don't want to do that. We want to avoid division by 0 at all costs. And so in this kind of problem, what would we put as our slope? Well, there is no slope. If there is no answer, there is no slope. Or another way of putting that is that the slope is undefined. It's so steep that we can't even define it because division by 0 is undefined. So vertical lines, undefined slope or no slope. Horizontal lines, you get 0 slopes, and then you get positive and negative slopes. So how to find the slope given 2 points you want to be proficient at, and hopefully these practice problems will help you. The last thing we'll take a look at here is the connection between parallel and perpendicular lines with slopes. And definitely this would be the more challenging, I would say, section of everything. So this is definitely the one that you want to clue in on the most. And so if we take a look here, we have the parallel line. And the directions will say something like this. I want to know I want you to graph a line that goes to the point 2, -1. So I want to graph a line that goes through 2, -1. So there's a point, but I don't know, how it's going to look. But then it says it's parallel to this. Now what we want to remember is that parallel lines have the same slope. So that's what you want to make sure you have in your notes right there, that parallel lines have the same slope. So if it's parallel to this equation right here, if there's somehow I can figure out what the slope of that equation is, then I know the slope of the line I'm trying to produce would be the same. So I go, well, how would I find the slope of this equation right here? Well, there's a few ways you can do it. You can either use a t-chart and find 2 points, and then you can go back to what we've been doing with our slope formula and use y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Another thing you can do, if you remember from Algebra 1, is to rearrange this and put it in slope-intercept form. So y equals mx plus b, and that will help you find slope. What we're probably going to use most right now, at least, is going to be a t-chart where we're plotting 2 points, but we're going to find the x and y intercepts, which we haven't talked a lot about, but you simply plug in 0 for x to find the y-intercept, plug in 0 for y to find the x-intercept. So this is what I encourage you to do, at least right now. And so when we plug in 0, what you'll notice is the 2x is going to vanish, and you get 3y equals 6. And so you can go ahead and solve for y by dividing by 3, and you get 2. So there's 1 point. And then we go ahead and we plot another point here, and what we get is 0 for y. We get 2x equals 6. And so we get x is 3. And so there's our 2 points. So if I wanted to find the slope of this, I would say, well, y sub 2, we'll call this y sub 2, this is y sub 1, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so what we get is negative 2/3 as our slope. Now that's the slope of this line. If my line's parallel to that line, it would have the same slope. That's what we need to remember. And so the slope of my line would also be negative 2/3. And so I go over here, and here's my starting point. Here's my GPS giving me directions. It says, look, you got to go up or down negative 2, and then you got to go to the right or left positive 3. So if I'm going to go negative 2, I got to go down 2. And then if I'm going to go to a positive 3, I go to the right 3. 1, 2, 3. And there's going to be our next point to where I can now connect the dots. And there's my graph. Now, as you take a look at this, it makes sense. It's going downhill, so that should be a negative slope, and that's what we have for something that's parallel. Perpendicular, on the other hand, they don't have the same slope, but perpendicular lines, now parallel, you can abbreviate parallel using the 2 lines up and down like that, and perpendicular, you can use like an upside down T. Okay, but perpendicular, they have what they call negative reciprocal slopes. Negative reciprocal. So again, this is something you would definitely want to have in your notes, just like the parallel. Same slope, negative. Now what does that mean, negative reciprocal slope? Because that doesn't make a lot of sense to a lot of students. Well, negative simply means opposite. So if you find the slope of one line is positive, then the other one has to be negative. It's complete opposite. Reciprocal means you flip. So another way of looking at it is flip, change the sign. That's how you'd find the slope of a perpendicular, is you simply find the slope of whatever you're trying to find the slope of, like in this case, find the slope of this equation, then once you find it, flip it, change the sign. Okay, and what the flip is the reciprocal, and the change the sign is the negative part. That's what those two come from. So if we go ahead and do that, I'm going to create some space here, so I'm going to get rid of this, and again, you can rewind it if you need to put it back in your notes. Okay, but let's get some space here and take a look at this right here. And again, what we need to do is we know it goes through the point negative 3, 1. So we go to the point negative 3, 1, negative 3, 1, put a dot, and now we've got to figure out what is the slope of this equation. So I'm going to use my handy dandy t-chart, which is just a sampling of points. I'm going to do the x and y intercepts again. So if I plug in 0 for x, what I get is 5y equals 10 or y equals 2. So I can come over here and put 2, there's a point. And then I go ahead and plug in a 0 for y, and I get 2x equals 10. And so in this case, x equals 5. And there's my second point. So now I label, I've got y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I've got 0 minus 2 over 5 minus 0. And you get negative 2 over 5. And again, we get a negative slope. However, that is the slope of this line. My line's perpendicular, so don't get going and try to do a negative 2/5 slopes, because the slope of our line is going to be the negative reciprocal of this one. So first off, I flip it, so it makes the 5 on top and the 2 on the bottom, and then I change it from a negative to a positive. So this is actually the slope of our line. So I have a point for our line, I have the slope for our line, I go 1, 2, 3, 4, 5, and then 1, 2, and there's my up 5 over 2. You could have gone down 5 and to the left 2. That gets a little trickier, but you can do 1, 2, 3, 4, 5, 1, 2. You can see it all falls on the same line. And so there's our graph. Once we know a point and once we know a slope, we can definitely graph these by those means right there. Okay. This is section 2.3, slope and rate of change. If you have any questions, make sure to stop in and see me.